Now, what is meant by modified bit or dirty bit? See, before seeing modified bit or dirty bit, let's see present or absent bit. Okay, what is meant by present or absent bit? See, just now I told that there is no necessity that every page of our process, which means every process, should be present inside the RAM. Okay, because only some pages will be present inside the RAM at any point in time. Now, what this bit is actually going to indicate is present or absent bit is indicating is it is going to indicate whether this entry's corresponding page is actually present inside the RAM or not. Okay, see this entry's corresponding page is this page. Now this page can be either present inside the RAM or it need not be present inside the RAM, right? It depends on the priority of this page. Now what this bit is going to indicate is, in the page table entry, what this bit is going to indicate is whether this page is present inside the RAM or not. See, whenever CPU wants to execute this page, what it will do is, you know that it will go first into the page table entry, right, in order to get the frame number. During that time, it will also see the modified bit. Okay, it will see the modified bit and understand that, sorry, it will see the present or absent bit, and it will understand that whether this page is present inside the RAM or not. In case if it is present, then it will go to this appropriate frame number and it will get the page. Okay, but in case if it is not present, which means in case if the bit is 0 here, what the CPU will understand is, okay, this page is not present inside the RAM right now, so somehow I need to bring the page from the hard disk into the RAM. Okay, this is what we mean by page fault. Okay, see, in case if CPU is trying to fetch a page, trying to fetch a byte within a page, and in case if the page is not present in the RAM, what CPU will do is it will take the process from the hard disk into the RAM. CPU will not do it, actually this is being done by our algorithms. Now an algorithm will run, our operating system will move the program from hard disk into the RAM, right? That is being decided by page replacement algorithm. So in case if the page which CPU is searching for inside the RAM is not present in the RAM, we say that as page fault. Okay. In case if the page is present inside the RAM, we say that as page hit. Okay, page hit means the page which CPU is searching for inside the RAM is present inside the RAM. So page fault means the page which CPU is trying to access is not present inside the RAM. Okay, that is what we mean by page fault. So we will see about page fault again later. Okay, while seeing page replacement algorithm, you will understand page fault very well. So we saw what is meant by present. See, we saw what is meant by present or absent bit, right? We also saw what is meant by reference bit. Now let's see what is meant by modified bit or dirty bit. See, what is meant by modified bit? See, let us assume you are actually using a Word document. Okay, a Word document has been already saved in your computer. Now this Word document will definitely present in the hard disk, right? Anything you save in your computer will definitely be present inside the hard disk. Now let us assume after some time in another day you open the document in your computer. Now what will happen? While opening the document, opening the document has to be executed by the CPU, right? So in order to execute that, this document should have been moved from hard disk into the RAM, because CPU cannot directly access the hard disk. So that document should have been moved into the RAM. Fine. Now we might do some changes to the document, right? For example, I can edit the document. Now whenever I edit the document, the changes have to be saved in our computer, right? The changes have to be saved. See, in case if I edit something, that has to be saved, right? Now let us assume this is the document. Okay, this is the document which is present inside the RAM. Let us assume this Word document has been edited by me. Now let us assume a higher priority process, say P4, needs to come into the RAM. Okay, P4 needs to come into the RAM, and it has been, let us assume we are using least recently used algorithm, which means we are going to replace the least referred page first. Okay, we are going to replace the least referred page, and let us assume process P2 has not been referred by the CPU during the recent times. Okay, that is still possible. Now in that case, what we will do is this page has to be moved into the this page has to be moved into the hard disk, and this page has to be moved into the RAM, right? This page has to be moved into the RAM. Now the changes which we made in this page has to be reflected back into the hard disk, right? See, in case if we have not made any change, it's fine. We can simply bring in process P4 here. Why? Because this process is already present in the hard disk, right? We have just taken a copy of this page into the RAM. See, again I'm telling you, everything will be copied from hard disk into the RAM. It is not moved, okay? It will be copied and it will be pasted, which means this page will be present in both RAM as well as hard disk. Now, in case if this page has not been, in case if the page has not been changed, which means it is present as it is. Now, or let us assume it is a read-only page. What do we mean by read-only page? This page can only be read. Okay, this page cannot be edited or written. Okay, that is what we mean by read-only page. We'll see that later. Now, let us assume this page has not been changed. Okay, in that case, we need not write back into the hard disk. Okay, we need not write back this page into the hard disk. That is what I mean by write back. Anything which you are going to move in, anything which you are going to save into the hard disk, which means the changes which you made in a page inside the RAM has to be reflected back in the hard disk. That is what we mean by write back. Now, write back has to happen only if the page has been edited, right? In case only if some changes has been made into the page. Whether changes has to be saved for a page inside the hard disk depends on whether it is a read-only page or not. Okay, whether some changes has been made or not. Now, that is what this is going to indicate. Okay, modified bit or dirty bit. It is going to indicate whether the corresponding page to this entry has been modified or not. Okay, see, this entry is going to indicate this page, right? Now, this page has been moved from hard disk into the RAM. Now there are chances that this page can be either modified or this pages need not be modified, right? Okay, both are possible. Now in case if the page has been modified, while moving this page into the hard disk, why are we moving it to the hard disk? Because some higher priority process needs to come into the RAM and there is no space inside the RAM. In that case, the changes made inside this page has to be reflected back into the RAM, right? So that is what we mean by write back. Now this bit is going to indicate whether this page has been changed or not. Okay, whether the write back has to be done for this page or not. In case if write back has to be done for this page, this bit will be 1. Okay, in case if you don't want to do write back, in that case this bit will be 0. See, what do we mean by we don't need to go for write back? In that case, what we will do is we will not place this page into the hard disk. Okay, we will not do that. What we will do is we will simply take this page and then we will overwrite over this. Why are we doing it? See, writing this page inside the hard disk is actually time consuming, right? We are just avoiding it. Why? Because no changes has been made to this page and a copy of this page is already present in the hard disk. So there is no point in writing back this page into the hard disk. Okay. So what we will do is, in case if no changes has been made, which means in case if the modified bit is 0, what we will do is we will simply overwrite this page with the higher priority process page. Okay. So this is, again I'm giving just a rough idea. Okay. We are going to see these things in detail. Fine. The ultimate goal of this video is to understand why we use all these fields. Okay. That is why I'm explaining all these things. Fine.